Okay, so on today, we are continuing our topic into thermodynamics. Remember what I said last week. Thermodynamics just basically means changes in heat and energy. Okay, right? The changes in the heat state or the energetic state of a particular object or substance. Changes in its thermal energy. Okay, so we started talking about this last week. Um, and on last week, I gave you guys a specific definition of temperature. Because remember, whenever we're talking about heat energy, we're talking about things that are hot and things that are cold. But whenever I say something is hot, whenever I say something is at a high temperature, what does that mean? Well, let me remind you guys by showing you all this video clip.
As the temperature inside the jar decreases, the water vapor molecules move more slowly. And as the temperature increases, the water vapor molecules move more quickly.
All right, guys, I'm going to pause that. Do y'all see that? That's what temperature is. Guys, whenever scientists are referring to temperature, they are referring to the average kinetic energy of all the molecules that make up a substance. Okay, that's what temperature is. That's what temperature is. It just refers to kinetic energy of the molecules. Remember what kinetic energy is. Kinetic energy is the energy of movement. So if you have, an object or some sort of substance that is really cold, its molecules are moving relatively slowly. But if you have a substance that is very, very hot, its molecules are moving extremely fast and they're very chaotic. They're all over the place. That's what we mean by when we say temperature. It's the average kinetic energy of a molecule in a substance, right? So anytime you use a thermometer, guys, basically a thermometer is just measuring kinetic energy. It's just measuring how fast the molecules are moving. That is what temperature is. Okay. Now, with that said, that allows us to easily transition to what we are talking about on today. Okay, let me go ahead and open up Schoology. Okay, so in Schoology for today, since we have an understanding of what temperature is conceptually, today we're going to be talking about temperature mathematically and understanding how to convert between the three different temperature scales. So today is February the 10th. It is a Wednesday. Okay. And so here's what we're going to do. This PDF file right here where it says temperature conversions practice problems, we're going to work on a few of these practice problems together, just so you guys understand how to convert temperature. And then I want to open up the multiple choice assignment for you all as soon as we get done going over a few of these practice problems. So that's what we're going to do on today. Okay. So now, let me open up Kami. Okay, so on today we're going to be dealing with Celsius, which is one of the temperature scales, Fahrenheit, And this one is probably one that you guys haven't really heard of, but there's also another temperature scale called Kelvin. And toward the end of this class, I'm going to explain more why we use Kelvin. But these two you guys should be familiar with, Celsius and Fahrenheit. So now, in our everyday lives, for the most part here in America, we use degrees Fahrenheit. So in Schoology, okay, there are a few practice problems here where we understand how to use these temperature scales and how to convert backward and forward between the two. For example, suppose you're given something in Celsius and you want to convert to Kelvin. This is the formula that you would use here. And guys, in just a moment, I'm going to do some examples here. Suppose you're given something in Fahrenheit and you want to convert to Celsius. You would use this formula. But what if you're given something in Celsius and you want to convert to Fahrenheit? You would use this formula. So the three formulas that you guys are going to be used are currently in Schoology. And you're going to use these formulas here to do the multiple choice assignment that I have posted. Okay, let's just work out some examples. Let me open up a new Kami file. Okay, let's see. How do I exit out of this? Sorry, guys, this screen just popped up. Oh, here it is. Okay. So, guys, we're just going to do some examples. I'm going to show you guys how to put this in your calculator properly. Just so you, whenever you guys are working on the multiple choice assignment, you guys know what you're doing. Okay. Number one says, convert the following numbers from degrees Fahrenheit to degrees Celsius. Okay, so, and I'm just going to do a few of these. We don't have to do all of them. I'm just going to do enough for you guys to get the basic example. For example, what is 0 degrees Fahrenheit? How would you write 0 degrees Fahrenheit into Celsius? Well, guys, since we're going from Fahrenheit to Celsius, we're going to go over here. We're going to look at this equation. If we wanted to know degrees Celsius from Fahrenheit, we would just plug in 0 into this equation, subtract it from 32, and then multiply by 5/9. So on number one, let me go here. So on number one, we're given 0 degrees Fahrenheit. So I'm going to plug in 0 degrees Fahrenheit into my equation, subtract it from 32, and I'm going to take all of that and I'm going to multiply that by 5/9. Now, guys, I'm going to say this. Whenever you guys are putting fractions in your calculator, if you're using a calculator like this and you're putting fractions in your calculator, please be sure to put this in parentheses. That way your order of operations are going to be correct. So do 0 minus 32, that in parentheses, and then that times 5/9. When you do that, when you guys put that in your calculator, you should get 17.8 degrees Celsius in a negative. So negative 17.8 degrees Celsius. So for this one right here, so that means for this right here, this would be negative 17.8 degrees Celsius. Let's do two more on the Celsius scale, just to be sure everybody understands what's going on here. So look at 32 degrees Fahrenheit. 32 degrees Fahrenheit is a freezing point of water. How do we figure out what that is in Celsius. Well, remember, Celsius equal to, so we're going to plug in 32 minus 32 times 5/9. So, number 30. So on number one, based on number 1b. So this is 1a, and then 1b. You would do 32 minus 32 times 5/9. Now, guys, 32 minus 32, that should be pretty easy. What 32 minus 32 is. 32 minus 32 is just 0. So this is 0 degrees Celsius. And by the way, guys, you all might know this as the freezing point of water. Water freezes at 0 degrees Celsius, which is 32 degrees Fahrenheit. So, guys, anytime it's snowing, snowing on site, you can guarantee that at some point in the atmosphere where that snow is produced, you can guarantee that the temperature is going to be 32 degrees or lower. Okay, right? It's going to be 32 degrees or lower because of it snowing. Obviously, it can't be 45 degrees Fahrenheit in snowing because, again, that's not the freezing point of water. So the freezing point of water is 32 degrees Fahrenheit, which is 0 degrees Celsius. Okay. And by the way, just so you guys know, the boiling point of water, so water boils at 212 degrees Fahrenheit, which is equivalent to 100 degrees Celsius. By the way, you guys can do the rest of these conversions by yourselves at the top if you guys want to be able to do that. Let me just be sure to put in the put the answers here so that in case you guys want to go back and check yourselves before you do your assignment. 70 degrees Fahrenheit is equivalent to 21.1 degrees Celsius. 98.6 degrees Fahrenheit is equivalent to 37 degrees Celsius. And then 100 degrees Fahrenheit is equivalent to 37.8 degrees Celsius. And again, guys, in order to figure out these answers, all I did was just use this equation right here, right? Because using this equation, by plugging in my numbers for Fahrenheit and going through the math, I can easily figure out Celsius. So this is mainly what you guys are going to be doing for your assignment. You guys are going to be using these equations here at the top. Let me just do a few more with you guys before I let you guys go. Number 2 says, convert the following numbers from degrees Celsius to degrees Fahrenheit. So now we're going from Celsius to Fahrenheit. Here we were going from Fahrenheit to Celsius, but now we're going backwards. So guys, whenever you're going from Celsius to Fahrenheit, this right here, this is the equation you're going to use right here. So let's see. For example, look at 2C. If I want to convert 70 degrees Celsius into Fahrenheit, basically what I would do is I would just plug 70 here into this equation here. So basically I would just do, so if you see this equation at the top, I would just do 70. And by the way, guys, whenever you multiply that by 9/5, please be sure to put 9/5 in your please be sure to put 9/5 in parentheses. So what I would do is I would do 70 times 9/5. I would do that first. I'll put that in my calculator first. So if I do 70 times 9/5. What I do, I get 126, right? 70 times 9/5 gives me 126. And then I have to take 126 and add that to 32. And again, I'm just showing you guys how to properly put this in your calculator. That way you get the right answer. That should give me 158 degrees Fahrenheit. Okay. So basically 70 degrees Celsius is equivalent, I'm sorry, guys, 70 degrees Fahrenheit is equivalent to 158 degrees Celsius. Okay, right? Because we're going from Celsius to Fahrenheit. So this is 70 degrees Celsius. So 70 times 9/5 gives me 126. plus 132 gives me 150 degrees Celsius, right? Hold on, wait a minute, wait. I'm sorry, guys. I'm messing up. I'm looking at the wrong thing. That's not the answer for 1C. That's the answer for 2C. I know I was confusing myself a little bit. No, 70 degrees Celsius is 158 degrees Fahrenheit. I'm sorry, guys. Hopefully I'm not confusing you. Wait a minute. Did I? How did I? Yeah. Okay, that's right. Yeah. All right, excuse me, guys. So 70 degrees Celsius. So 70 times 9 fifths. 70 degrees Celsius times 9 fifths plus 132 gives me 158 degrees Fahrenheit. Sorry, I was both of these have 70 on it, so I was looking at that wrong. Okay, but yeah. So 70 degrees Celsius is equivalent to 158 degrees Fahrenheit. Okay, so just remember, guys. Just remember, whenever you guys are putting this in your calculator again, I would just do 70 times 9 fifths, and I would do that first with 9 fifths in parentheses, and whatever I get to that for that, I just add that to 32 to get my answer in Fahrenheit. Okay. And guys, I want you guys to go home and well, you aren't home, but I want you guys to practice the rest while you guys are at home before you do the assignment. So I'm just going to give you the answers: 32. 89.6, 209.5, 212, 413.6. Again, guys, if you guys want to practice putting this in your calculator yourself, just to be sure you get the right answer, I'm just giving the answers for you all. Okay. Now, lastly, let's move on and let's talk about the Kelvin scale. Let us talk about the Kelvin scale. Okay. Which is right here on number 3. So in order to convert from Kelvin to Celsius, that is actually pretty easy. We're just going to go up here to the top right here, and you're going to look at these equations right here. So whenever look at 3A. 3A says convert from 250 degrees Kelvin to Celsius. So look right here. If I want to know how to convert from Kelvin to Celsius, basically I just plug in my number here and subtract it from 273. So this is actually really easy to use. So if I just plug in 250 into the equation, so 250 minus 273, that gives me minus 23 degrees Celsius. Okay. So what about going the other way, guys? What if I want to go from Celsius to Kelvin? So for example, look at 3D. If I want to go from 55 degrees Celsius to Kelvin, how would I do that? Well, I'll just go up to this equation right here at the top. So if I'm going from Celsius to Kelvin, basically I will plug in 55 here. Instead of subtracting, I'm going to add. So 55 plus 273. So if I take 55 plus 273, what I get 328 degrees Kelvin. Okay. So going from Kelvin to Celsius is actually pretty easy. And of course, let me just give you the rest of these numbers. So this answer here is 66 degrees. This number here is 31.9. Again, this is in case you guys want to, calculate these yourselves. And 290 Kelvin. And guys, look at look at letter D where it says 383 degrees Kelvin to Fahrenheit. Okay. Guys, if you notice, we don't have an equation at the top that goes directly from Kelvin to Fahrenheit. Okay. But guys, if you guys get a question like this, on a quiz or a test, here's what you want to do. You want to convert from Kelvin to Celsius first. So convert from Kelvin to Celsius using this equation here. And then after you do that, use use this equation right here to go from Celsius to Fahrenheit. So you're going to use two equations on that one. So that will look something like this. And again, I already did the math, but I just want to show you guys what that will look like. So if I put this in my calculator, if I put 380 degrees Kelvin in my calculator to convert to Celsius, I would get 110 degrees Celsius. Okay. And then once I have that number in Celsius, then I go to that equation at the top, and then I put that into my other equation to convert that to Fahrenheit, which is 200 degrees Fahrenheit. And that's my answer for D. Okay. So that's how you convert from Kelvin to Fahrenheit, even though you don't have an equation at the top that goes directly between the two. Okay, I think I'm gonna stop there on the math. Just know that you guys have these formulas in Schoology. Just click on that PDF file, and you guys will use these formulas to do that assignment that I have posted. One more thing that I want to say about Kelvin, guys, Kelvin is very useful in physics and chemistry, is because Kelvin is what is known as an absolute scale. I know you guys are used to dealing with Celsius and Fahrenheit, but Kelvin tends to be the scale that scientists use. The reason why they use this scale is because it has an absolute limit to it. In other words, guys, if you take something and you cool something to absolute zero, absolute zero is what is known as 0 degrees Kelvin, and this is the coldest temperature ever. So this is the coldest temperature ever. So guys, there is nothing in the universe that can get colder than 0 degrees Kelvin. That's why we use Kelvin, is because there's an absolute limit to it. Nothing can get colder than 0 degrees Kelvin. It's not possible. Nothing can get colder than 0 degrees Kelvin. If you want to convert that to Celsius, 0 degrees Kelvin is exactly equal to minus 273 degrees Celsius. That's actually pretty cold, guys. If you guys know, the freezing point of water is 0 degrees Celsius. But if you take ice and you cool it down to minus 273 degrees Celsius, that's the coldest that water can get. That water cannot get any colder than that. Minus 270 degrees Celsius is equivalent to 0 degrees Kelvin. There's no such thing as something being colder than that temperature. That is the absolute lower limit to temperature. Nothing can get colder. This is why scientists use the Kelvin scale. It's because the Kelvin scale has a zero value, right? And nothing can get colder than that. So that's why it's really useful for scientists. I'm gonna stop sharing my screen in a moment. But in Schoology, this is the assignment you guys are gonna be doing. I'm gonna publish that in just a moment. Give me just a second. See, some of you guys are just now coming in and you're asking for the attendance form. Guys, I just put the attendance form in the chat box. If you need it. Are there any final questions for me before I let you guys go to work on the assignment? Any final questions for me? All right, guys, give me just a second while I get that assignment unpublished and posted for you guys, so that way it's visible. If there are no final questions for me, you guys are free to go. Have a good one.